Chris Tuin tested conductive concrete on a 150-foot bridge near Lincoln, Nebraska, where he says it successfully de-iced the surface. University of Nebraska–Lincoln University Communications. When Chris Tuin was a Department of Defense contractor in the early 1990s, the Air Force asked him to think of something that could de-ice his airfields around the world. Heavy cargo aircraft were landing on icy runways and skidding off, he says, so they wanted to find out some innovative way to de-ice the runway. The challenge: he couldn't use any salt or de-icing chemicals because of the damage they can do to concrete. Tuin had studied how to use steel fibers to reinforce concrete. He decided to embed them in the runways and run a low-voltage electric current through the steel to heat the concrete, so the snow and ice can just melt off the surface. Think of it as a heating blanket, he says. It worked, and now researchers at various universities are working on surfaces that can de-ice themselves, so salt or de-icing chemicals don't have to be used on roads and other paved surfaces in the winter. The Federal Aviation Administration supports this work because keeping runways clear is a big problem for airports in cold places. Tuin says the Air Force didn't scale it up at the time because of budget cuts. But Tuin, now a professor of civil engineering at the University of Nebraska–Lincoln, didn't forget his idea. Starting in 2002 and working with the Nebraska Department of Transportation, he ran a 5-year test on a 150-foot-long bridge near Lincoln, Nebraska. He says a 208-volt current running through electrodes kept the bridge free of ice during 15 major snowstorms at the amazingly low operating cost of about $250 per storm. The conductive concrete involves adding steel fiber and carbon to the concrete mix, he says. While regular concrete costs $120 per cubic yard, the conductive concrete costs $350–400 per cubic yard. But in the long term, Tuin says the conductive concrete means fewer de-icing chemicals in the ecosystem, and concrete that lasts longer and costs less to maintain. Tuin says he's working on several projects overseas, and he just finished running FAR-funded tests on a 200-square-foot site in Nebraska this year. He points to this time-lapse video of the slab in action and says the results are excellent. He isn't the only one doing this kind of research. Last year, Halil Ceylan, a professor of civil, construction and environmental engineering at Iowa State University, installed two 15 by 13.5-foot slabs of conductive concrete at a corner of a hangar at Des Moines International Airport. It's in an area for smaller planes, and Ceylan can turn on the heated pavement with an app and watch the snow and ice melt away. In the surrounding controlled areas, ice and snow was accumulating. But in our test slab, ice and snow was melting away, he says. Halil Ceylan of Iowa State University says heated test slabs at Des Moines International Airport stay clear of snow without plowing. Halil Ceylan, Program for Sustainable Pavement Engineering Research at Iowa State University. Ceylan says there were 7 or 8 snowstorms in Des Moines last winter, and the conductive concrete worked every time. If de-icing chemicals aren't needed, he says, concrete roads and runways can last longer. We live here in Ames, Iowa, he says. If there is a brand new concrete pavement constructed, they put a sign on the side of the road saying, "New pavement, no salt on it in the first year, because it will be very harmful to put de-icing chemicals on that concrete." Ceylan says his technology will cost 40% to 50% more than regular concrete, but that the benefits to airports, fewer flight delays, fewer cancellations, less money spent on de-icing chemicals, outweigh the cost in the long run. Philadelphia International Airport already has 2 similar systems in place, says longtime engineer and manager Alan Moore. One of the gates where catering trucks enter the airfield has electric coils under it, because the vehicle barrier makes it impossible for trucks to plow snow there in the winter. Also, a sloped service road that baggage tugs use has hot water pipes running under it so the snow and ice will just melt off it. Moore says the slope makes it hard to plow. The airport is still considering whether to test Ceylan's conductive concrete technology, but civil engineering specialist Amna Ali says one possible additional benefit is that the airport would use less de-icing chemicals such as sodium acetate and potassium acetate, reducing their runoff and potential harm to the environment. A U.S. Geological Survey study of potassium acetate in airport runoff in 2009 concluded that it may harm aquatic life. Meanwhile, other researchers are looking at solutions that don't involve electricity. For example, engineers at Drexel University, Purdue University and Oregon State University recently published the results of a method using paraffin oil. They soak tiny porous rock fragments in it, then use those fragments to make concrete. When it gets cold enough for snow and ice to form, the oil freezes and the process releases some heat, which happens when any liquid freezes, preventing ice and snow from forming on the surface. During testing, the researchers added 5 inches of artificial snow, which disappeared in a day. Alan Yu reports for WHYY's Health and Science show, The Pulse.